So sleepy.
Well, I got up at 6, like I usually do, and I was like, 10 more minutes. So I set a timer for 10 minutes, but I didn't push start. So I woke up at like 8, which is like...
So you should be nice and rested.
Well, yeah, but it threw off my schedule, so I got too much sleep. I get too much sleep, I'm tired.
I wish I had too much sleep.
No way that works.
What works?
Yeah, it's not supposed to. I mean, it accidentally worked that with those numbers, but it's not supposed to work.
Okay.
That's the point.
Good. Where is everyone?
Well, the bell just rang. So
That's true, yeah.
And there's probably a couple people gone for AP test.
I think I turned in one.
You turned in something.
I turned in 2 things, I'm pretty sure. Turned in my...
Here's
What worked?
112. But you didn't.
I didn't what?
This question 60, it looks like you did it, but it's not on here. Oh. This one you need to keep for now.
Oh, okay.
You'll turn it in when you do the rest.
Gotcha. So 1 to 111.
The worksheet, 2.5 worksheet. Or the one that you numbered as 111, so you would know what it would be.
I wasn't here yesterday. I just need to do like the topics.
There's part 4 that was really short. That's on the desk in front of the handouts. And we need to do one FRQ that you can pick from. That's on the agenda for the class recording.
It's like
And part 3 is due tomorrow.
Part 3 they turn in tomorrow.
Oh.
So you can turn that in. And then I think probably about 30 minutes of time that they work on the
Like a review circuit Monday?
I mean, it's use substitution, so you should know how to do it, but I gave it to you a couple weeks ago and have been asking you to chip away at it as you had time. It should be 127 in your binder.
Okay. So just part 4 is the only thing I knew that's new.
It's the only new thing to pick up, yes.
Yeah.
Right.
It should be a relatively easy quiz. Yeah, I just don't like writing all of it. I'm annoyed.
Is Luke AP testing today?
Oh yeah, I think the computer science.
I mean, I don't know that he's.
Yeah, CSA
I
is today,
can't
so
remember
yeah.
everybody's.
Ben and Luke are in CSA, so they shouldn't be here.
Okay, that would be those two. Brian, probably computer science.
I don't think so.
Oh.
I think. Yeah, Ben's in CSA.
Okay, either way, our bells are turned off, so it is time to get started a minute ago. I just wanted to pay attention there. All right, we're going to start off with our quiz. So this will be 113. But if you did not give me the 2 homework assignments that I've been asking for in Google Classroom, which is 111, which was the 2.5 worksheet, and 112, which was the book problems from 2.5, then this would be your last chance to get full points on those. So make sure your name's on those and come throw them in the box, please. Then our quiz is no calculator, and we do need to go over that short handout that y'all picked up on the way in, but we'll only need about 15 minutes for that. Oh, sorry, I didn't mean to do that. No calculator. You're welcome to take as long as you need to. But if you're still working like the last 15 minutes, for yours, have you finished the final review yet? Okay. I'll give you the choice. You can either do this if you feel like you're prepared for it and you think it'll help your grade, or I can excuse you from it and you can work on your final review. I have no preference. Because a couple of those questions will be on the final, so it's good that if you know them. Okay. So before you get too deep in here, go ahead and number it as 113. Go ahead and put your name on it. Bless you.
Bless you.
Each question has point values out to the side. They total up to 20. So not a ton, but I guess it's worth the same as the 2 homeworks you just turned in. But since every question's worth more than 1 point, every single question can get some partial credit. So please show me as much as you can. Also, with a quick glance, you should notice it looks a whole lot like that first worksheet that we did, the 2.5 worksheet. So if you looked over that stuff, then you shouldn't feel like you have any surprises there. on now. Good, because you guys should be able to finish up the handout this way and not have any homework like the other classes had. But you should have picked up a handout on the way in this morning, so if you did not, please go and grab it, 114. So really the last of the big topics for sure that we are going to review is graphing rational functions. And so to graph a rational function, you have to be able to analyze the function, which basically means can you understand enough about what's going on to graph it without a calculator. So there's a ton of things to find. There's x-intercepts, vertical asymptotes, holes, horizontal asymptotes, y-intercepts, slant asymptotes, or oblique asymptotes, and finding more points and then knowing what all of that stuff looks like and putting it on the graph. So individually, each of those things is not too bad, but it is a lot of information if you hear it all at once. So that's why I have this handout, so that we can look at 3 of those things, and all 3 of these basically have the same work behind them. So we are going to look at, given a rational function, how would you find if or where it has holes, x-intercepts, or vertical asymptotes. So when we say something like a rational function or a rational number, really a rational number is like anything you can make a fraction out of. So even like the number 3 is a rational number because you could put it over 1. But when we're talking about rational functions, we pretty much mean something divided by something. So we're looking at functions that are fractions. And again, these 3 kind of get clumped together, so I'm not just picking random stuff, but the work behind finding one of these is almost the same work as finding the other 2. So for an x-intercept, anytime you're doing any math and you're trying to find an x-intercept algebraically, what do all x-intercepts have in common? What equals 0?
X. Or no. Y equals 0.
Okay. So if we want the function to equal 0, and all of our functions are going to be written as fractions for the next couple weeks, when does a fraction equal 0? Okay, when the numerator is 0. So to find x-intercepts, although this is not, you know how to deal with fractions, you know if it's 0 divided by something else, it's 0, you know if y is 0, it's an x-intercept. But we can sum this up to say x-intercepts are going to be the x values that make only the numerator equal to 0. I'm going to emphasize the word only, and you should understand why here in just a moment. If the numerator is 0, then the fraction is 0. If the fraction is 0, y is 0. And if y is 0, it's an x-intercept. Now you are more than encouraged to make this more detailed or write it out in a different way at the end of today's. Okay, another thing we're going to look at is where would the vertical asymptotes be. So vertical asymptotes are vertical spikes in the graph, and so this is where your function tries to go to infinity on one side and negative infinity on the other side. And the reason why it shoots up to a super big number or a super small number very quickly is because we're getting super close to dividing by 0. So vertical asymptotes are going to be x values that make only the denominator equal to 0. Because we can't divide by 0, but as it gets really close to that, again, your fraction just gets really big, infinity, or really small, negative infinity. Now, the reason why I need to highlight the word only and underline it is because holes will occur anytime you have an x value that makes both the numerator and denominator equal to 0. Keyword there is both. So visually, An x value can only be one of these three things. If it's a whole, it couldn't be an x-intercept or a vertical asymptote. If it's an x-intercept, it can't be a whole or a vertical asymptote. And if it can't be if it's a vertical asymptote, it could not be a whole or an x-intercept. So, consistent with these definitions, it's one of the three, but never multiple ones. If it's only the numerator x-intercept, only the denominator vertical asymptote, but if it's both, it is instead a whole instead of either one of those. I guess this doesn't matter too much, but for those of you doing calculus next year, I think that there's usually 2 questions on the AP test for calculus that are not specifically calculus related, and one of them is usually this one about vertical asymptotes. Now, we don't reteach this in calculus because we know you learned this in Algebra 2, and we know that you redo it in pre-cal with us, but you don't have to know any calculus to be able to do that question when they ask it. They don't ask it every single year. So, okay, so let's look at a couple of these together, and then I will give you some time to try them and see how they go. Alright, so what you should notice about these three, again, we're going to do a bunch more stuff, but these are the only 3 we're focused on today. You need to know what numbers make the numerator and denominator 0. So, the easiest way to do that is to think about the numerator factored and the denominator factored. Because if you have the numerator factored, you should be able to quickly see which numbers make it 0. So what numbers would make it 0 in number 4? Okay, and what numbers make it 0 for the denominator?
4 and -2.
Okay. Again, you don't have to factor as fast as me, but it is important that you factor correctly. And then these 3 answers are going to come along pretty quickly now because we've done the bulk of the work. If there's any number that makes just the denominator 0, it's going to be a vertical asymptote. Vertical asymptotes are vertical lines though, so we need to write it as a vertical line equation. Any numbers that make just the numerator 0 are going to be x-intercepts. X-intercept is a point, so write it as a point. But if there's any numbers that make both 0, that is going to be the x value of the whole. Now we actually need to come back up here and write a little bit more about how to find its y value, because you are expected to do that too. But to find the x value of the whole, it would just be 4, because 4 makes the numerator and denominator 0. Now to find the y value, I'm going to highlight this entire line because this is usually one of those things that doesn't stick as well as the other stuff for students, partly because when we work these rational function questions, some problems don't even have a whole. So you don't get to practice this in every single question. You get to practice it in every other one. But the y value is going to come from plugging in the x value of the whole into the reduced fraction. You're going to plug in the x value of the whole into the reduced fraction. The reason why you're not going to plug it into the original one is because you're going to get 0 over 0. And we kind of looked at this a little bit with limits earlier this semester. 0 over 0 can be anything. It could be 0, it could be undefined, it could be 7, it could be 2.5. Just depends on the question. It depends on how fast the numerator is going to 0 and how fast the denominator is going to 0. If you plug in 4 here into the factored form, it's still going to go into 0 over 0. You need to plug it into the reduced fraction. So have these factors cancel out, and then you plug it into what's left over. The fact that 4 is making the numerator and denominator 0 means there should be a factor of x minus 4 in the numerator and denominator to cancel out. And when you plug that in, you're left with 4 plus 1 on top over 4 plus 2 on bottom. So the y value of its whole is 5/6. Does that sound familiar? You remember doing some of that last year? All right, let's, I'm not gonna graph every one of these today, but maybe the two that would go over. So let's look at what the graph looks like. So here's the function. And again, there's a lot of other stuff we're gonna analyze about this. But one thing we said was the x-intercept, and I don't want to flip back and forth, so what did we say the x-intercept was? So notice we said there was only one x-intercept at -1, and the graph confirms that. It only crosses the x-axis once, and it's at -1. We said there was one vertical asymptote at x equals, and at x equals -2, notice this vertical spike in the graph. As it gets close to dividing by 0, it either shoots to infinity or to -infinity, depending on what side of the graph it's on and which way it was heading before that. But that's the only vertical asymptote. That's the only one we found algebraically, and we can see it's the only one visually. What about the hole? Do you see the hole in the graph? Where is there supposed to be a hole?
4 times 6.
Okay, so when x equals 4, y is supposed to be 5/6. Look at the calculator. Calculator does a very poor job of showing you if there is a hole. It's not that your calculator is doing anything wrong, it's just that it needs to graph all the points right before the hole, all the points right after the hole, and it has to just, it kind of rounds with these pixels. It's got to decide, am I going to color in this pixel or not? So it doesn't look like there's a hole here. But if you do trace 4 enter to jump to that spot, notice it says when x is 4, y doesn't exist. That means there's a hole there. And the only way you can kind of check to see if your y value of the hole makes sense is just move your cursor a little bit to the left, and the y value is about 0.83. Move your cursor a little bit to the right of 4, and the y value is about 0.84. And on the home screen, what did we say the y value was? 5 something? 5/6? We are saying it's at about 0.83. Do you see how that matches up with what the graph says? So your calculator is not programmed to, you know, draw you a big hole here and identify, hey, here's his y value. So that's kind of the closest that you can get. But we can still check most of that pretty quickly. Okay, let's look at one more together, and then you guys will have about 15 minutes to do the other couple. But again, I'm trying to do you a favor here by, if you feel comfortable with this today, then it will make the other couple more things next time seem much more manageable. If all of this is thrown at you at one day, then it does seem kind of overwhelming. But for all 3 of these, I need to know which numbers make the numerator and denominator equal to 0. It looks like the numerator has a GCF and it's a trinomial, so you always want to factor it completely. Always GCF first if you can. And then the bottom only has a GCF, but that is still the type of factoring. And then now that it's completely factored, what numbers will make the numerator equal to 0?
0.
Okay, x equals 0 at 0. What else? 2? -2 and -1. And the numbers that make the denominator 0 are, and if you know those 3 definitions at the top, this is all you have to do to finish your work. Any number that makes just a denominator 0 is a vertical asymptote. Any number that makes just a numerator 0 is an x-intercept. And any number that makes them both 0 is the x value of the hole. But to find the y value of the hole, you need to plug in the x value into the hole of the hole into the reduced fraction. So if 0 is making the numerator and denominator 0, there should be at least that factor to cancel out. So if you reduce that, let those cancel out, and plug it into what's left over, you would be left with 2 times 1 over 5, or 2/5. Okay, and if you want to, I'll leave it up to you, but if you wanted to graph this in your calculator, again, we're not going to let you have a calculator on this test because it does it for you, but it will cross the x-axis 2 places, 2 times, and it should be these 2 values. There should only be the 1 vertical spike in the graph, and it should be at the line x equals -5. And then your calculator is not going to show it very well, but if you do trace 0 enter, it's going to tell you when x is 0, y doesn't exist. But if you move your cursor a tiny bit to the left of 0 and a tiny bit to the right of 0, you're going to see that the y values are around 0.4, which is 2/5. That's the closest that you can do to check that. So again, these 3 just kind of all group up together. You have to know which numbers make the numerator and denominator 0 for all 3 of them. So really being able to work one of them, it's only a tiny bit of work to know how to do the other 2 as well. Okay, so I would like you to practice the other 5, please. And y'all have 15 minutes of class, so if you can do 1 every 3 minutes, then you shouldn't have any homework. But if you can't finish those in time, then please do that before Friday. So we'll talk about this again on Friday, but just for a moment. But we need to talk about the other methods too so that we can start practicing it all together.